Okay. Shh. Once you've written your name on it, open it up, and you'll notice that the first page says page 16. And remember, that's because we've already done half of this unit. Remember before the break we took 7 questions off the Unit 2B test? On your midterm day, we just took those 7 questions. So today we're starting the second half of the unit, which is on totally different material. It's over relations and functions. And so next Friday, after we finish, we will finish that test, okay? Next Friday, we'll take the other 11 questions. I'm going to teach today, tomorrow, Friday, Monday, Tuesday, Wednesday, review Thursday, finish the test Friday. And then it'll be graded that day. All right, here we go. A relation is a set of ordered pairs. Okay, everybody should know what an ordered pair is. An ordered pair is just x, comma, y in parentheses. But if I just wrote one point or one ordered pair like 2, 3, that is not a relation because that's not a set. To have a set, you must have 2 or more. So I'm going to add some more. I'm going to put -1, 7, 0, 4, and then I could continue and make as many ordered pairs as I want, but I don't have to. I have enough to be considered a set. You have to have at least 2 ordered pairs to be a set. Okay? That's also known as a relation because it's a set of ordered pairs. Okay, any questions so far about what a relation is? The set of all first coordinates of the ordered pairs is called the domain of the relation. Okay, the set of all first coordinates of the ordered pairs is called the domain of the relation. So, in that very first ordered pair I wrote, which one of these is the first coordinate? The 2. In this ordered pair, which one's the first coordinate? The -1. Which one's the first coordinate? 0. So that is the set of all the first coordinates, and that's called the domain. What else do you notice about those 3 numbers I underlined? What else do they have in common? Well, they're all x values, right? So that lets you know that the domain is the set of all the x values. Now, when you're asked to write out domain, you write it in braces, just like we put for the set of ordered pairs, but you have to list your numbers in order from least to greatest. So what's the smallest x value we have? And then the next smallest? And then the largest? 2. So that's the domain of that set that I made up. The domain is just the set of all x values. And when you write it down, you list it least to greatest. Okay, the set of all second coordinates is called the range of the relation. So in this relation that I made up, this is a second coordinate, this is a second coordinate, and this is a second coordinate. And what else do you notice about those 3 things? Those are your y values. So the range is the set of all the y values. And just like domain, when you list them out, you list them in order from least to greatest. So what number would I put first? Yeah, but you're looking at x values, the y values. 3, and then 7. Okay, so writing out a set of ordered pairs is one way to represent a relation. Another way to represent a relation is to use a mapping diagram. Okay, so this time, instead of writing out this relation as a set of ordered pairs, we're going to put it in a mapping diagram which looks like this. So go ahead and draw 2 ovals over to the side. Okay, the first oval is for your x values. The second oval is for your y values. Okay, domain, range. When you write in your x values, or otherwise your domain, you write them in order from least to greatest. So what would that be? Right, -1, 0, 2. When you write in your y values or your range, you write them from least to greatest. So what would that look like? 3, 4, 7. Then once you have them listed inside the ovals, you're just going to connect them. Like the first point is 2, 3. So I'm going to draw a line or an arrow from 2 to 3. The second point is -1, 7. So I'm going to draw a line from -1 to 7. And then the final coordinate of my relation that I just made up is 0, 4. So I'll draw a line from 0 to 4. And that's what a mapping diagram looks like. Now, it may not always look like that, like a little star or X. Sometimes they look messier, but it's just you connect the X value to its corresponding Y value according to the information they gave you. Okay, so we know that the elements of the domain, those are our X values, right? Another thing that we can call those X values are inputs. Okay, so sometimes you may hear somebody refer to all the X values as inputs. And you may hear them refer to all of the Y values as outputs. Okay, so far we've learned how to write a relation as a set of ordered pairs, just listing out the points. We learned how to write it as a mapping diagram, and you can also represent it as a table. Okay, the table would look like this. The x's would go in the left column, the y's would go in the right column. You're going to list your x values from least to greatest. So for this particular example, the lowest x value is -1, then 0, and then 2. But then for the y values, you can't list them from least to greatest. You have to list them according to who they correspond to. Like -1 has a y value of 7. 0 has a y value of 4, and 2 has a y value of 3. Okay, so that's just another way to represent a relation. Okay, and then another way to represent a relation is to draw its graph, which just means you would take these 3 points and just plot them on the coordinate plane. Are there any questions so far about what a relation is and how it can be represented? Okay, so when I ask you for domain, you're looking for what? The x values. When I ask you for range, you're looking for the y. X values can also be called inputs, and y values can also be called outputs. All right, let's do a separate question. So this question has nothing to do with the previous numbers, okay? Find the domain and the range of the relation shown. Okay, the relation is represented this time by a graph. So the first thing we should probably do is identify the coordinates of each of those 4 points. So for this point furthest to the left, what is its coordinate? Or what are its coordinates? -5, 3, because you have to go left 5 and up 3 to get to it. Okay, what is the next point's coordinates? 0, 3. And then the next one is 2, 3. And the last one is 4, 3. Now, since this is more than one ordered pair, you'll put it in braces, showing that it's a set of ordered pairs. Okay, so this is a relation because it's a set of ordered pairs. So now we've represented it in 2 different ways, as a list and as a graph. We can now identify the domain and range. Okay, the domain would be what? No, she's right, because isn't -5 smaller than 0? So -5, 0, Right, they were already in order for you, correct? Why do you think that is? Very good. When we were naming the points, their coordinates, we went left to right. Okay, what about the range? What is the lowest y value? They're all the same. And you could write 3, 3, 3, 3. I guess I said enough times. But you don't have to. On a test, they'll only write it once. You don't have to list repeaters. The braces, just so that it's a set. That's just notation. You draw like a U and then a V and then a U. Okay, now turn to page 17. Okay, so far we've learned 4 different ways to represent a relation. We've learned that you can write them as a list of ordered pairs. You can put them in a mapping diagram, which is the 2 oval things. We learned that you can write them in a table, and then we've learned that you can plot them on a graph. We have not talked about equations yet, but we will get to that later in class. All right, so example number 2. Represent the relation shown in the mapping diagram as a set of ordered pairs, then determine the domain and range. So we have 3 things to do. The first thing we've got to do is write them out as a set of ordered pairs. Well, what's the easiest way to tell how many ordered pairs are going to be there from that mapping diagram? Count what though? Well, but sometimes you may have more than one arrow coming out of a number, so the best thing to do is count the arrows. So 1, 2, 3, 4, 5. That means there's going to be 5 ordered pairs. Okay, the very first x value is 0, and it has an arrow going to the y value of 0. So your first coordinate is 0, 0. So that means your second coordinate would be 1, 4. Your third coordinate would be, and then your next one, and your last one, 4, 4. Okay, now that we've written it as a set of ordered pairs, we're ready to write down the domain and the range. What is the domain? 0. Right. And then what's the range? 0, 2, 3, 4. Because remember, you don't have to list repeaters, and you write them in order from least to greatest. Writing the domain and range when you're given a mapping diagram is very easy, because in a mapping diagram, they're already in order, and you only list it once. So this is basically the domain and range already written out for you in the mapping diagram. All right, a function is a relation that assigns to each element of the domain exactly one element of the range. Now, I'm going to show you a different way to remember that because that's confusing. All right, now remember, this is Math World and it's made up, so don't get too upset about what I'm about to say. Okay, it's just a way to remember this. In Math World, the X's are going to be boys and the Y's are going to be girls. Okay, each ordered pair represents a date. Okay, so in date 1, boy 0 took out girl 0. In date 2, boy 1 took out girl 4. In date 3, boy 2 took out girl 2. In date 4, boy 3 took out girl 3. And then in date 5, boy 4 took out girl 4. Did anybody cheat? Who cheated? Girl 4. Because girl 4 went on a date on Friday night with boy 1, and then on Saturday night she went out with boy 4. So she's a cheater. But in the math world, it's okay for girls to cheat. Okay? Guys cannot. If a guy cheats, it's not a function. If a girl cheats, it's okay though, so this one's still a function because only a girl cheated. Well, because we know how to function with handling more than one guy. Y'all don't know how. Yeah. Okay. Shh. And no two elements of the domain are mapped to the same elements of the range. It's called one-to-one mapping. A horizontal line is a constant function. No. A linear function is a function whose graph is a line or part of a line. And then if a vertical line passes through no more than one point of the graph of a relation, then the relation is a function. Now that's probably something you've heard before. It's called the vertical line test. Okay, go to the next page and we'll talk about how it works. Okay, number 3 says, use the vertical line test to determine which graphs represent functions. So right now, all 4 of these graphs are relations, okay? All 4 of these are relations because think about it. Aren't all of these graphs just lots of ordered pairs that are just connected? So all 4 of them are relations, but only 2 of them are functions because only 2 of them pass the vertical line test. If you take a vertical line and you draw it through this first curvy relation, does the vertical line cross it more than once? No, it only crossed it one time. So A is a function because it passed the vertical line test. The vertical line only hit it once. But if you go over to B and you draw a vertical line through its relation, is it a function? No, it failed the vertical line test because it hit it twice. Now, let me explain this to you in another way. If I were to draw some little lines on here, 1, 2, 3, 4, 1, 2, 3, 4, wouldn't this point be sitting at over 4 up 2? And this point would be at over 4 up 4? And then don't we have a boy that's going out with 2 different girls? Okay, so that's what causes it to fail the vertical line test, because you have 2 points with the same x value but different y values. So they're on top of each other like that, and it fails the vertical line test. Okay, what about C? Would it pass the vertical line test? Yes, no matter where I draw it, it only hits it once. So C is also a function. And then what about D? It fails the vertical line test because it hits that relation in 2 different places. So it's still a relation, it's just not a function. Okay, now turn to page 19. Find the domain and range of the relation represented by the set and then determine if it's a function. Okay, so for this relation, because it's a relation because it's a set of ordered pairs, what is the domain? Okay. Yeah, well, yes, but sometimes he can repeat and it still be a function if it has the same y value beside it. Okay, so -1, 0, 3 is our domain because those are the x values in order from least to greatest, and we didn't list any repeaters. What about the range? -7. Okay, is this relation also a function? No, why not? Right, -1 repeats and it has 2 different y values, so it's not a function. Your x value has to have only one y value. You can't have 2 different y values. If the boy cheats, it's not a function. Right, right. All right. Yeah, it doesn't negate itself. Number 2. Graph on the coordinate plane the relation represented by the following mapping diagram and then determine if it's a function. Okay, well from the mapping diagram, what is the first coordinate that we're going to plot? Negative 1, 5. And then what's the second point? Negative 2, 0. And what's the third point? Right, because there were two arrows coming from the negative 2. And then what's the fourth point? Negative 3, 5. Okay, so this is the same relation. It's just represented in two ways. First, a mapping diagram. Second, a set of ordered pairs. Now we're going to put it on the graph. How do we plot the point negative 1, 5? Okay, how do you plot the point negative 2, 0? Left 2, and then you don't go up or down. How do you plot the point negative 2, 4? And then how do you plot the point negative 3, 5? Okay, so once you have your relation graph, you can see that it's not a function because first of all, it fails the vertical line test because right there it hits it twice. And you can also see that in the set of ordered pairs, negative 2 has two different y values. So this one's not a function. All right, number 3. Find the domain and the range of the relation given by the equation y equals x squared. Given the domain is 1, 2, 3, 4. Okay, so they gave us the domain. They want us to find the range. And all they gave us is an equation this time to represent the relation. Well, domain is what? X values. So aren't 1, 2, 3, and 4 all x values? So couldn't they simply be substituted in the x place? So the first time, wouldn't that be y equals 1 squared, which is 1? And then the next time you'd insert the 2, or input, that's why it's called an input. Y equals 2 squared is 4. And then y equals 3 squared is, and y equals 4 squared is 16. And you notice every time I said y equals, and that's because range is the y values. Right, you would plug in the numbers for, like if they gave you the domain, you'd have to plug them in wherever the x is and solve for the y. Okay, so now let's try number 4. The relation given by this equation, y equals x minus 3, has a domain of negative 1, 0, 1. Find the range. So what are we going to do to find the range? Just plug them in. These are our inputs. We input them into the x place and then take away 3. So that would give us what numbers? Negative 4, negative 3, and negative 2. Okay, now just for time purposes, we're going to skip the next one for today. Go to the last page, number 20, or page 20. All right, number 3. Which of the following relations are functions? Write yes if it is, no if it's not. Okay, A is a relation that's been given to you as a graph. Is it a function? No. Why not? Right, it fails vertical line test. Well, I almost choked on my gum. It is. It fails the vertical line test. Okay, what about B? No, why not? Right, the x value of 0 has two different y values. Shh. Okay, hold on. I'm still videoing. C, is this one a function? Yes, because no boys even went out more than once, so there wasn't even a possibility of cheating here. For boys anyway. A girl could have still cheated, but remember, it only matters if the boy cheats. Okay, on your assignment sheet, you need to write today's date, and then your homework is page 21 and 22.